In this video, I'm going to show you how to calculate standardized beta weights for a logistic regression. And the example I have here is absenteeism and performance as predictors of turnover. And turnover is a binary dependent variable, 0 and 1s. The formula for estimating standardized beta weights, which I have symbolized here with beta, capital Beta, is to obtain the unstandardized beta weight for the particular predictor times the standard deviation of that predictor, IV for independent variable, multiplied by the Cox-and-Snell R value, which is obtained from the logistic regression, and then divided by the standard deviation of the log odds predicted probabilities. And the way you get the standard deviation of the log odds predicted probabilities is to use the logistic regression equation that's estimated and reported by SPSS. So let's get those now for these data. So go into Analyze, Regression, Binary Logistic, and I got the dependent variable here and the two predictive variables here, and click OK. And if I scroll all the way down, I'll get the variables in the equation, and all I need is the intercept plus the unstandardized beta weight associated with performance, and additionally the unstandardized beta weight of absenteeism. And with this, I can calculate the log odds predicted probabilities. Go on to Transform, Compute, and I'm going to call this predicted log odds. And I need the intercept, so 3.689 plus the product of absenteeism and the unstandardized beta weight for absenteeism, which is 0.015, and then plus, open parentheses, performance multiplied by the performance unstandardized beta weight, negative 0.631. Now to get even more accuracy, you might get more decimal places associated with the values, but 3 should be fairly good. Click OK. And this creates a new variable called predicted log odds, and there's a standard deviation associated with these values. So if I go into Analyze Descriptors Frequencies and then put that here and get the standard deviation, the standard deviation is estimated at 0.92346. So now I have the value that needs to be specified in this portion of the formula. The rest of this is fairly easy to obtain. So let's actually put this into an Excel sheet. So let's do absenteeism first. Absenteeism. And let's just say we need B, and we need the standard deviation of the independent variable, and then we need Cox and Snell R, and with the standard deviation of the predicted probabilities. So the unstandardized beta weight for absenteeism is 0.015. So put that here, 0.015. And the standard deviation for absenteeism, I'll get the standard deviation for both of them. Analyze descriptors frequencies. So absenteeism and performance, I need the standard deviations. Yep. And okay, so the standard deviation for absenteeism, 27.639. 27.639.4, and the Cox and Snell value, the R value, not the R squared, so 0.123, so I need to square root that value to get the corresponding R. 0.123 square rooted is 0.3507, 0.3507, and then the standard deviation that I estimated just over here of the predicted log odds, 0.9234, 0.92346. And so with these values, I just need to solve for this formula, which is the unstandardized beta weight multiplied by the standard deviation of that predictor times Cox and Snell R value divided by the last term. So let's go over here. So we've got equals B2 times C2 times D2 divided by E2. And that yields a value of 0.157, which is essentially the same as that reported in the textbook. Depending on what level of decimal places you use for your calculations, you'll get a slightly different value at the third decimal place. Now, what about performance? Well, I already have the Cox and Snell, so I can actually just copy and paste that here. And this isn't going to change either, so I'm going to copy and paste that there. Now I just need the unstandardized beta weight for performance, which is negative 0.631, negative 0.631, and the standard deviation for performance, which is 1.22, 1.2200. And now I can solve for that. I can actually just drag that down and get that calculated as well, negative 0.292, which again is essentially identical to what was reported in the textbook. Again, it'll vary somewhat depending on the level of decimal places you use to perform the calculations. So these are the standardized beta weights associated with the two predictors in the logistic regression. And so now I can make some level of at least numerical comparisons between the strength of the predictors with respect to contributing to the logistic regression equation. And I mentioned in the previous video that the Wald statistics offer some basis for comparison with respect to evaluating the strength of the predictors. Certainly the unstandardized beta weights don't give you much sense of that, given that the standard deviations were radically different between the two predictors. And then expressed in a standardized format, we can see that performance is twice the size as a contributor to the regression equation expressed in standardized form. So that is how you can calculate standardized beta weights for a logistic regression.